Hey folks, welcome back to geometry class. We're going to get into a new unit on surface area, and we're going to start with understanding three-dimensional figures and their cross sections. So in this particular lesson will probably be 3 videos again because I talk a lot. We're going to talk about vertices, faces, and edges, and then we're going to get into Euler's formula. Yes, that is pronounced Euler's, and then we'll talk about cross sections. So first, let's talk about just three-dimensional figures in general. I've created like a little rectangular prism here, and it's all taped up for a reason. But this is a three-dimensional figure. You can hold it in your hand, you can spin it around, a lot of stuff. But the point of this lesson is to take this concept and to make it completely flat. You're going to have to visualize this being the reality of what we're studying, that we can hold it in our hands. And so we have vertices, faces, and edges of figures. And of course, vertices are little corners, like the little points, right? So in this particular figure, I have 1, 2, 3, 4 vertices on that side, then 5, 6, 7, 8 vertices total. And then we have faces, which are the flat parts. Okay, so you have a face here, and a face here, and a face here, right? Those are faces. And edges are not the points, but the corners, right? So an edge here, and an edge here, and there's an edge, and there's an edge. And so those are vertices, faces, and edges. And so what we're going to do is jump into that particular concept of vertices, faces, and edges and start counting them. So remember, what we have to do is take a diagram like this and imagine it's something that we are holding in our hand. And that's the hard part, because everything about this is about visualization, and we'll talk about visualization quite a bit. So we have a two-dimensional figure. This is a pyramid. So we have a two-dimensional figure, but we have to imagine that it's 3D, right? So we're imagining it's three-dimensional, and so we're going to count the vertices, the edges, and the faces. Okay, so you remember what the vertices were? The vertices were the points, right? The little pointy pieces. And so when we talk about vertices of this particular figure, we want to name them all first, right? Then we can count them up later. So in this particular figure, we have a vertex at H, right? So there's a vertex, a point. You can stick your finger on that. So we have H, D is a point, E is a point, and F is I forgot E, and then F is a point. And then what about that G? What's happening in this diagram? Notice the dotted lines, right? The dotted lines are giving it depth. So you want to pay attention to your diagram, see where the dotted lines are, and it gives you depth, right? Perspective. The dotted lines are basically behind the figure. So that point G back there is that bottom corner of the pyramid. So we have to imagine that's what's happening. So in this case, the vertices here, there are 5 of them, right? So we have 5 vertices, and that's going to be important later, you'll see. So that's how we figure out the vertices. And now we talk about edges. And so we can look at that picture, that diagram, and figure out what were the edges. Now remember before, what was an edge? And the edge is the thing that you can run your finger along. And that's an edge, and that's an edge. An edge. Where 2 planes meet, right? They'll make an edge. So we look at our diagram and figure out, well, where are our edges? Well, the H is the top of the pyramid, so we have an edge going from H to D, so that's an edge. So we have an edge on HD. That's a line segment, right? And again, from the top, we have an edge going from H to E. That's a line segment. We have an H to F. That's a line segment. And then remember that depth piece, that from H to G, right? It's depth. It's going back there. So HG is a line segment. Now, that's not it. There's more edges, right? We had the edges from H coming down, but what about the edge of the base, right? So we have an edge along the front from D to E. I'll save the back for last. And then along the front from E to F. So that's an edge. Now, what about going to the back? So from F to G, and then from G to D. And so we have all of these edges going on in this diagram. So we want to keep that in mind, the depth part as we're moving along. So how many edges did we end up with? We had 1, 2, 3, 4, 5, 6, 7, 8 edges. And then lastly, the faces. Okay, so what were the faces here? And again, remember what the faces are. The faces are the flat parts. Okay, so it's a face. Faces are the flat parts. And so we want to look at the faces. Now, this is going to be kind of interesting. if we're looking at this diagram and we notice, let's take that front face. Okay, so we'll call it the front. All right, so we look at that front face. It's facing us. It's this triangle here. That's the front face. It's a triangle. It's triangle HDE. And so in the front, we have a triangle HDE. That's how we're naming it. And then from this particular diagram on the right-hand side, okay, so we have a right face as well. So the right face is another triangle, isn't it? It's triangle EHF. So that's another triangle. Now going around the diagram, we have a back face, right? So there's a back face as well. We want to keep that in mind. That back face is going to be a triangle as well, triangle HGF. And then, of course, we have a left face as well. So we want to visualize what's happening here. And so the left face, also a triangle from H to D to G. And so it's important to visualize what's happening. So we have our front face, right face, back face, and left face. But what about the bottom? The bottom is also a face, so we have to keep that in mind. There is a bottom as well in this figure. If the figure had a top, there'd be another face. Now, is the bottom a triangle? Okay? And we look here, we can visualize the bottom is not a triangle, so we will not be calling it a triangle. This is a quadrilateral, however. We can't say it's a rectangle or a parallelogram or anything. We don't know anything about it. We just know there are 4 edges, there are 4 sides. That's only a quadrilateral. So we can name it a quadrilateral and then give it its name by vertices, D, G, F, E. And so it's quadrilateral D, G, F, E. And those are the faces of that particular diagram. Okay, so we can see here what's happening. So of course, how many faces? 1, 2, 3, 4, 5 faces as well. Okay, so there's some interesting number of things to go about. So let's see if we can do the same thing, but for this next diagram. So take a look at this next diagram. We want to figure out the number of vertices, edges, and faces in that polyhedron. Polyhedron, by the way, that's a neat word. Polyhedron, many sides. Okay, so it just means a many-sided figure, polyhedron. Okay, and it gives depth. It's a three-dimensional polyhedron. It's three-dimensional shape with many sides. So here's our next one, kind of like a wedge of cheese, or whatever. I'm sure it has some particular name. I don't know what it's called, but I call it a cheese wedge. It makes me hungry. So the first thing I want to count up is the vertices. So we look at all the vertices. So there's U, R, and S, vertex at U, R, and S, and T, and then W, and V. Those are all the vertices, and there's 6 of them. Okay, so we have 6 vertices. We have, the next thing we're going to look for are the edges. And notice how I'm abbreviating, and there's a very particular reason why. And so the edges now are all the different segments. So we have a segment from U to R. We have a segment from U to T. We have a segment from R to S. We have a segment from S to T. We have a segment from T to W. We have a segment from S to W. We have a segment from U to V. We have a segment from R to V. And we have a segment from V to W. Now, a good thing to do is as we list them, let's mark them off, right? So we had UR, we got that segment, and UT, got that segment down there in the back, right? And RS at the top there, and then ST down that back corner there, and TW down there, and SW up there, right? And then UV down here, and then RV up here, and then WV. So we got them all, right? We ticked them all. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we have 9 edges. And then lastly, the faces. And so we want to look at basically the front face, what's facing us first. And the front face is a triangle. Okay, so hopefully we can see that front face is a triangle. It's triangle URV. That's important. We have the left face is not a triangle. The left face is a quadrilateral. Hopefully you see that. The left face is a quadrilateral, URST. And so we can name that. Now the back face, right? The back face is also a triangle. Okay, so we have triangle STW. And that's it for front, back, left. We don't have a right face. We don't have a right face. But what we do have is a top, right? We have a top to this, and the top is a quadrilateral. So another quadrilateral at the top, right? So we have RSWV. RSWV. And if we have a top, of course, we have a bottom as well. And so the bottom is UTWV, and that's another quadrilateral. So quadrilateral UTWV. And how many faces is that? So we have 1, 2, 3, 4, 5 faces. Okay, so we have 5 faces as well. And some neat number stuff. And so I just wanted to start this first video off with understanding vertices, faces, and edges, and making sure that we're visualizing three-dimensional figures. We'll come back for the second video, and we'll start learning some neat mathy stuff with these concepts. So see you guys in a bit.